When you have behavior that varies by who or how something is done, and the set of roles or strategies is relatively stable, the role or the strategy patterns becomes incredibly powerful. Let me walk you through a complete transformation so you can see exactly how this works. Imagine you have a paid service that starts simple but grows into a conditional nightmare. Now, you might look at this and think it's not too bad, but here's the thing, this is just the beginning. In a real system, you'll have 6 or 8 or 12 different operations. Each operation has different permission rules. Some roles can do certain things, but only under certain conditions. The complexity grows quadratically. But watch what happens when we apply the role pattern. First, we define the capability interface. Now, here's the key insight. Instead of having the service figure out what each role can do, we let each role figure out its own behavior. Each role becomes a complete self contained implementation of the business rules for that role. Let me show you what the admin role looks like. Notice what's happening here. The admin role knows exactly what an admin can do and how to do it. There's no conditional logic. It's just straightforward implementation of admin behavior. The audit messages are specific to admins. The operations are unrestricted because that's what admin means. Now look at the editor role. See the difference? The editor role has its own implementation of the deletion rules. It knows that editors can only delete pages they own, and it enforces the rule itself. The audit messages is specific to editors. The business logic is encapsulated within the role. And here's my favorite, the guest role. The guest role is beautifully simple. It just says no to everything, but it does so consistently and with proper audit logging. Now, here's the payoff. Look at what happens to the paid service. That's it. No conditionals, no branching, no complex logic. The service has become a simple delegation layer. Each method is one line that says, let the role handle this. This transformation gives you several profound benefits. First, each role has a single responsibility and handles its own behavior. There's no God object that knows about everyone's rules. Second, your service logic becomes linear, no branching needed. When you're debugging or tracing through the code, there's only one path to follow. Third, extension becomes trivial. Add new roles without touching existing code. Want to add a moderator role? Just implement the interface. Fourth, testing becomes much more focused. You can test each role independently with its own test suite. But here's a real aha moment. You've eliminated the combinatorial explosion. Instead of testing every role in every method, which would be 4 roles times 6 methods times various edge cases, you test each role's implementation of each method independently. The complexity becomes additive instead of multiplicative. Now, the role pattern is just one of the tools in our toolbox for internal conditionals. Now, when you're dealing with large but static matrices like pricing tiers or complex permission systems, decision tables or lookup maps work wonderfully. Now, let me show you another transformation. Imagine you have a pricing service that starts simple but grows into a conditional monster. Here's what this might look like. We have a calculate price method that takes the customer tier, product type, and quantity. Then we have a series of if else statements. If the tier is premium and the product is software and the quantity is at least 100, we give a 20% discount. If the tier is premium and the product is software and the quantity is at least 50%, is at least 50, give a 10% discount. If it's premium and hardware with at least 20% items, with 20 items, sorry, we give a 15% discount, and so on. Now, this might continue for maybe 20 more combinations that you have to maintain. Every time the business adds a new pricing rule, you have to modify this method. Every time they change an existing rule, you have to find the right condition to modify. And good luck figuring out if you have all the edge cases covered. But watch what happens when we externalize this into a decision table. First, we create a simple record called pricing rule that captures the customer tier, product type, minimum quantity, and discount multiplier. Then in our pricing service, we have a list of pricing rules that we load from configuration. The load pricing rule method returns a list of pricing rule objects. Notice that these could come from a CSV file, a database, or any configuration source. Now, our calculate price becomes beautiful. We get the base price for the product, then we stream through the pricing rules, filtering for rules that match the customer's tier, product type, and quantity. We find the first matching rule, apply the discount multiplier, and if no rule matches, we return the base price with no discount. Now, this is much better. The pricing logic has become a simple filter operation. The business rules are explicit and tabular. You can literally hand this list to a business analyst and they can verify its correctness. More importantly, this approach is data driven, which means rules can change without code changes. You could also load these rules from a CSV file, a database, or a configuration service. The third technique for internal conditionals is higher order functions. This works beautifully when the client already controls the branch decision. Let me show you what I mean. You might have code like this where you're processing different types of users. You have process active users that loops through users, checks if each user is active, and if so, sends a notification, updates their last seen time, and records their activity. Then you have process subscribed users that does the same thing but checks if the user is subscribed. Then process premium users that checks if the user is premium. Do you see the duplication? Every method has the exact same processing logic. Send notification, update last seen, and record activity. The only difference is in the filter condition. This is a classic case where higher order functions shine. We create a process users method that takes a list of users and a predicate function that defines the criteria. The method streams through the users, filters them based on the predicate, and processes each matching user. Now, the usage becomes completely declarative. Process active users becomes process users with a list of users and a user dot is active predicate. Process subscribed users becomes process users with a list of users and a user dot is subscribed predicate. What you're saying is process users who are active or process users who are subscribed in a way that's impossible to misunderstand. The filtering logic is separated from the processing logic and you've eliminated all the duplication.